Smoke containment and control, engineering a safer escape from a building fire. Fire safety in any building is an intricate field that extends beyond preventing flames. Smoke is often more deadly than the fire itself, and poses significant risks due to its toxicity and the challenges it creates for evacuation and firefighting with the speed at which it creates untenable conditions. Effective smoke containment and control systems are pivotal in mitigating these hazards. Where buildings are likely to have occupants, smoke management systems are combined with smoke detection and alarm systems to alert occupants to the emergency while simultaneously working to contain and control the smoke. Fire engineers need to understand fire development and heat release rate. In simple terms, the ingredients for combustion are oxygen, fuel, and heat. The heat release rate quantifies the amount of heat energy a fire releases over time. It is typically expressed in kilowatts or megawatts and is a key parameter in understanding fire growth, behavior, and the potential for fire spread. There are 4 stages of fire development. Fire growth. This follows ignition when there is an abundance of oxygen to feed the fire. During this stage, fire spreads from one object to another by convection and/or radiation. Convection is when the flame contacts the next object. Radiation is when the thermal radiation of the flames and hot smoke is enough to ignite the next object. In a building fire, the smoke plumes are rising and forming a smoke layer under the ceiling and flowing out of doorways. Flashover. This is the rapid change from fire growth to the full developed fire. A person in the building could be watching the fire thinking it is slowly growing and they have time to escape. But then all of a sudden it reaches flashover, the entire room is on fire and they are trapped. Fully developed fire. In this stage, everything that can burn is burning. Now the heat release rate depends on the amount of air that reaches the fire via openings like windows and doors. Fire decay. In this final stage, the heat release rate is decreasing, either because the fire has been suppressed or because the fire has run out of things to burn. In thick smoke, visibility is severely reduced, causing people to move slowly and become disoriented, which increases their exposure to the smoke. Carbon monoxide is a leading cause of death in fire-related incidents due to its toxicity. There are often many other toxic gases released during a fire. If a fire occurs at night when occupants are sleeping and their sense of smell reduced, the smoke can lull them into a deeper sleep from which they often don't wake. Smoke management systems are broadly categorized into containment systems and control systems. While containment systems focus on creating barriers to restrict smoke movement, control systems aim to manipulate airflow to direct or remove smoke from critical areas. Smoke containment systems employ physical barriers to limit smoke leakage between compartments within a building. Key components include smoke walls and doors, designed to impede smoke movement. These barriers are tested for leakage rates under specific conditions of pressure and temperature. Automatic smoke curtains, flexible, deployable screens that seal off large openings during a fire. Innovations like pneumatic seals enhance their effectiveness. Dampers and penetration seals, installed in air ducts and joints, these components prevent smoke leakage and maintain compartmentalization integrity. Smoke lobbies, mandatory in certain buildings, these act as buffers between fire-affected areas and escape routes. Smoke control systems utilize mechanical or natural forces to manipulate smoke flow. The primary strategies include smoke exhaust systems, mechanical fans or natural buoyancy forces expel smoke, maintaining a safe air layer for occupants. Pressurization systems. By increasing air pressure in certain areas, these systems prevent smoke infiltration into escape routes. Smoke reservoirs. These ceiling-level compartments work with exhaust fans to contain smoke and facilitate removal. Opposed flow systems. Though less common, these systems use directed airflow to counter smoke migration. Natural smoke venting manages smoke and heat using natural airflow principles, such as buoyancy and wind effects. When a fire occurs, hot smoke rises. Strategically placed vents at the highest points of a building allow this hot smoke to escape, reducing the buildup of toxic gases and heat. Simultaneously, fresh air inlets near the floor replace the exhausted air, creating a flow that keeps escape routes clearer for a longer time. Effective smoke containment and control systems are vital in reducing fatalities and ensuring building safety during fires. As urban landscapes evolve, so must fire safety strategies. Enhanced standards, rigorous testing, and innovative solutions are necessary to address the complexities of modern building designs and ensure the safety of occupants and emergency responders.
This presentation was brought to you by CJK Fire and Safety. Don't forget to like, share and subscribe.